let's press on quickly. I think we're about 10 minutes later than scheduled. So I've got one big challenge in this whole presentation. That's because I have way too many slides. So I visited a developer conference last weekend, and I came back with so many good ideas, so many things I want to talk about. So I'm gonna try and cram in as much slides as I can. But it'll be me talking. The slides will be supporting. So I'm going to talk about hypervisors in a hyperconverged world. Specifically, what has the HCI world done for the hypervisor in the last couple of years, and where are they evolving the hypervisors to? So a quick agenda. I'm going to do a quick introduction into HCI, do a little history lesson. So how did we get there? Look at some current plays, hypervisor plays in this world. And look at the future. So after the hypervisor, containers and unikernels, like has been mentioned before today. And I'll do a quick wrap up. So let me start by introducing myself. I'm Joep Piscaer. I'm a CTO at my company OGD. We are a Dutch MSP. I have a bunch of these logos on top, which describe what I do for fun in my free time. I blog on Virtualization. Highly recommend you check that out. And also I'm a VMUG leader for what is probably the biggest VMUG in the world, back in the Netherlands. So let's start defining what this world of HCI and hypervisors really are. So Stephen mentioned software-defined storage earlier today, and I really don't know either. Same goes for the couple of other definitions. So I can probably talk about converged infrastructure, what it is exactly. Same goes for hyperconverged, Docker versus containers and unikernels. But there's just one I won't really touch, and that's the SDS definition. So it's kind of hard to define what is what, which is which. I'm not sure either half of the time. But let's start and look at hyperconverged infrastructure, what it is, where it came from. So it's basically really simple. It's this plus networking. So maybe one more time, right? So it's compute. This is a motherboard with CPUs, RAM, interconnects, everything on top. Plus storage in every which way. I won't define what kind of storage. That'll get me in trouble with Stephen probably. And it's networking, which I won't ever start to describe when Tom is in the room. But basically, that is hyperconverged infrastructure, right? It's not that hard. It's just a combining of physical components into a new form factor. So the key points in hyperconverged infrastructure are the appliance-based model. It's a simple 2U, 4U server, which got storage, some kind of networking, and some kind of compute combined in one physical appliance. Usually has a node-based distributed architecture, and it's been the hallmark of simple management, complete stack management, to do all kinds of things like automation, orchestration, and it's got that whole given that it's a node-based distributed architecture, it's got this pooling of resources as one of the key concepts of HCI. So no more silos to deal with, no more dedicated storage network. The physical stuff just becomes really simple, right? All right, let's move on to a little history. So when I was about 20, I dropped out of college. I started looking for a job. I rolled into IT. And I started in IT just when this whole physical to virtual movement were starting. So my first couple of jobs were actually installing physical servers, managing them, et cetera. And after about a year, I discovered this whole virtual thing. So vMotion was a cool thing. It blew my mind, actually. And it was just, it was becoming more and more efficient to virtualize instead of having physical servers. So you didn't need to order a physical server, rack and stack it, provision it, et cetera. You had templates inside of the virtual environment, which helped out. You did consolidation, so you ran 20 servers or 20 VMs on a single physical server, which cut down cooling costs, power costs, etc., and the availability ran up, right? VMware HA, one of those, cool techniques VMware brought to the market. It helped bring high availability to any kind of application. And by any kind of application, that was one of the key things there, because you didn't need to change the application, talk to the application owner, do anything or change anything, be able to move a physical machine into a virtual machine. And that was, one of the big pluses of virtualization 10 years ago. So one of the other movements that came about just a couple of years later is the combination of compute and storage that commoditized the underlying hardware, right? So you had these management layers on top, which kind of hid all the complexity behind it. And it paved the way for automation, because now you have this separation, all the hardware stuff in the back and all the, the logical application-related stuff or VM-related stuff in the front. So vendors actually converged all these components, combining, storage, compute, networking, inside of these big, big pod-based designs, the old converged infrastructure. And those are pre-integrated siloed racks based on the old stuff, the old SANs, the old networking stacks. They scale by the rack, so if you have a resourcing problem, you just bought another rack, which again contained everything, inside of that rack. So more compute, more storage, more networking, etc. Had a big plus though. You had only one throat to strangle, right? If there's a supportability issue, the platform didn't work, your application wouldn't perform, you had just a single throat to strangle. Big plus in my book. But then again, it was often retrofitted with old management tooling, old provisioning tooling, etc. So it wasn't, the best of solutions, right? Remember this game, anyone? Who knows what it is? The Incredible Machine. I used to play this when I was a kid. Maybe that tells you how young or old I am, I'm not sure. So this whole converged infrastructure methodology led to what we now know as HyperConverged, combining it into much smaller, much denser architectures, and introducing that distributed scale-out architecture in favor of the monolithic architecture we had before. So no more, monolithic SANs, no more monolithic networking designs or management tooling around it. And instead of having a management tool per layer, so one management tool for storage, one for networking, one for compute, one for provisioning, et cetera, the hyperconverged world is actually integrating all those bits and pieces into one vertical stack with one management tool on top. So that's for SMBs or small enterprises, that's a pretty big plus, because now instead of having 20 different management consoles to do whatever you need to do on that infrastructure layer, it's just one console. It'll be more limited in some ways. It'll be simpler in a lot of ways, but it might be just what you're looking for, right? And like I mentioned, the hardware layer it makes the physical layer much simpler. So it's this new appliance form factor for all x86 compute. And that hardware is built just by the regular vendors that we know and love or hate maybe. And there's no particular lock-in from the hardware. There are vendors that actually sell their HCI solution with hardware included, but that's not a bigger lock-in than buying traditional CI infrastructure. All right, now it gets interesting. So we talked about the hardware side of things, traditional stuff, converged infrastructure, hyperconverged infrastructure. We haven't really talked about the stuff running on top, right? So this morning, and Nigel touched on this a couple of times, we talked about the whole pets versus cattle, right? So on the left side, you have these pets. You know them, you love them, you treat them well. On the right side, you have cattle. They're numbered. If one is sick, you shoot them, and you move on to the next one. So the pets are the VMs that we all have, basically left over from the previous era, where we had physical machines that needed hugging, needed attention, etc. They got a human readable name, very unique. Not sure if this comic is readable for you guys, but it's a discussion where you have to pick a server name for a new server, which is probably the hardest decision you have to make whenever you deploy a new VM, right? So cattle, on the other hand, are treated like a herd. This guy's actually drunk, maybe. I'm not sure. But cattle is very process-centric, right? It's not based on a individual, it's just a process. You have cattle, and they'll either give meat or milk, and you have your whole process pretty much standardized for the outcome. So it's not the thing itself you're interested in, it's the outcome of the thing you're interested in. It lives for a shorter amount of time, and it's taken care of by automated systems. So let's look at a couple of the players in the hypervisor market in HCI. So I'm not going to talk about the HCI vendors themselves. I'm going to talk about the hypervisor plays on top of it. So it's pretty simple. It's usually the hypervisors that you already know and have deployed in your environment. So it's going to be vSphere, Hyper-V, maybe a KVM derivative like OpenStack or some vendor-specific implementation. And we do see Zen Server in the wild as well. So, does it really matter which hypervisor you've deployed anymore? It's not for the features anymore, right? So my first contact with VMware was a VM being vMotion from one host to the other. And 10 years ago, that was cool, right? That was, pretty nifty. These days, all the hypervisors can do it. They have vMotion, they have DRS-like systems, they have HA, et cetera, et cetera. So while vSphere is still the undisputed leader in this space, it's not going to matter anymore for long because all the hypervisors are playing catch-up. So it's more of the ecosystem of management tools around it. Does it do proper backup? Are there monitoring system integrating with this specific hypervisor? Those are considerations nowadays, not the hypervisor itself. So it's kind of commoditized in that way. But still, it's important to, as a HCI vendor, to decide, am I going to purely support a existing hypervisor, or am I going to build my own, right? So why would a HCI vendor build their own? It's going to be either reduce complexity, and it's going to be more control over the entire stack. So instead of having a vSphere management console here and a storage console there, they'll be able to deploy one simple HTML5 UI with all the bits and pieces in there to manage your infrastructure. And it could be that it's because you want to add public cloud integration into your platform, make migrations to and from the public cloud easier. So the whole OpenStack implementation hype, where developers are asking for an OpenStack API instead of a vSphere API because they're used to it. So the most obvious hypervisor to include in a build-your-own solution is going to be KVM, right? So that's the latest iteration of a free and open source hypervisor, kernel virtual machine it stands for, and it's not really useful or valuable in a pure standalone KVM deployment, and that's not really because it's open source or it's free, but it's more of a supportability, integration, full stack outcome. So because KVM is only one small part of all the things you need to deploy a full stack, KVM in itself is not really valuable. So you need to bundle it up, include it in the whole development of your own stack. And a couple of guys are actually doing it. So Nutanix has built Acropolis, which is based on KVM, but it's got so much more than just KVM. And Skill Computing has done the same. It's also based on KVM, but it's a complete solution. And I overhear a lot of these statements like, well, KVM and OpenStack are complex, difficult, horribly to integrate. And this is a picture by Jonathan who maps like all the OpenStack components and all the VMware components. It's unfortunate that you can't actually see the most of it, but I recommend you going to vertexpert.com. This picture is up there on that website. And you can compare how how complex these solutions really are if you map them one to one. So still we're not there. We've got an hypervisor, we've got an HCI solution. And the next phase in this, physical to virtual, virtual to virtual pets to virtual cattle to something else is going to be containers. So we heard a little bit about that earlier already. And moving to containers is basically the next step in this whole evolution. And a container is to the hypervisor what the hypervisor was to the physical machine, right? It hides even more layers of the infrastructure, even more layers of complexity. And containers, to that point, can run in VMs. They can run on bare metal, although I'm not sure why you would want to run containers bare metal at this point, given the massive ecosystem around the whole VM with vSphere and Hyper-V. But containers will run and kind of do already run on optimized hypervisors. So instead of deploying an actual VM, a VM gets deployed automatically underneath. So you don't need to manage it. It's not something you actually see, and that complexity is being hidden from you as an administrator. But it does allow you to do all the the VM-like operations. So you can back it up, you can monitor it, you can do logging on it, et cetera, et cetera. So that's easier for the current model of IT operations that are deployed inside companies right now. And as a result of this move to containers, storage will move closer to the application. So it's going to be more file-based, more object-based. It's going to include more metadata instead of just the files and just the objects. All right, so containers versus VMs. Containers are pretty good at scaling stateless application architectures. So it's not really meant to run your Exchange inside of. Wouldn't recommend it to do so. But it's really aimed at the stateless distributed application architecture. So every time you open Gmail, a container gets spun up with your specific information, your data processing, basically your Gmail instance, totally inside of a container, right? So that is a whole different world where it's just a very small portion of the application that is run inside of a container, instead of having that that specific user portion run inside of the Exchange server that's on all the time. That's a completely different world. Specifically, it's legacy enterprise apps like Exchange versus all the new stuff Netflix and Google and Facebook and Twitter are developing. So VMs are, for the foreseeable future, still the best solution for stateful legacy applications. Even more so because of the whole management and security tooling around it for monitoring, for backup, et cetera, et cetera. But running containers in VMs is a way of your IT department to help you move forward as a developer department while the IT still gets to maintain their grip on the environment. So containers in a VM approach, like I said, it can be a smart move. And you can do it with a couple of different options. So you can run it inside of a Nano OS like Photon, like Windows Nano, like CoreOS. It's smart to run it inside of a container because you'll have the Docker APIs or the other container APIs published to your developers, so the developer can actually use those APIs instead of having to learn something new. And again, IT Ops is still able to maintain their, all their VM-centric tooling. So just to close off, I want to talk about a new concept. So we talked about physical, we talked about pets and cattle and containers. And like I said, I went to FOSDEM, and a guy mentioned the flock of birds as a new a new concept to take into account. So containers are still relatively big. They're smaller than VMs, but they're still relatively big because every container in a Docker world anyway is still running a full OS on the back end. So it's still Ubuntu with all the device drivers for all the physical stuff you won't ever need. It's still got all the application libraries you don't need for this specific application. It's got all the software that needs patching, needs attention in any way, which leads to more bugs. It leads to security holes, bigger attack surface, and it does still use more compute resources. So CoreOS, PhotonOS are kind of trying to solve this, but remember these are the platforms that you run your Docker instances on, not in. So these are the base images that you install inside of a physical machine or a virtual machine where you run your Docker instance. So it's very comparable to a host OS. And that's not solving the problem. And while Docker is moving to Alpine Linux as an example, it's a very small, very optimized operating system. It's still not solving the issue. So unikernels are kind of a good step in the right direction. They are solving that whole big operating system problem right in the middle by removing the operating system as an entity. So what you do is you actually package everything you need from the application level down into the application, right? So you don't have a general purpose OS anymore. It's just a very small piece of software that only includes all those bits that you need to run the application. So it doesn't have any device drivers for physical servers anymore. Smaller attack surface. It's faster to boot because it doesn't have so many files in the base image. And one of the biggest pluses I learned about is no more redundant isolation. So usually you'll have a couple of layers to go through inside a stack, inside a virtual machine, before you can actually execute code, right? So you've got an isolation boundary in the hypervisor, and you've got one between the kernel space and the user space inside of an operating system. All that gets is removed in a unikernel simply because it assumes it doesn't have to have all these isolation because it's a single process application or a single process design. So a flock of birds is actually taking this whole unikernel step methodology one step further, where it's just code running somewhere. You don't have to deal with anything on the back end anymore. So it's very much like AWS Lambda or the event-driven logic with IFTTT. Anyone use that app? I use it a lot. It's basically inputting a couple of lines of code. If this happens, then something else will be triggered. You're perfectly able to upload your code into something like AWS Lambda or Webtask or Stack Hut or and just even obscure more and more layers of that infrastructure, and just input your code somewhere in a platform, and it'll just run. It's even more simple. So as a wrap up, I know I had a lot of slides and I know I talked a lot, but as a wrap up, so HCI is making the hypervisor invisible, hiding complexity behind the full stack of management. And HCI vendors are replacing current hypervisors with their own special sauce, basically. VMs are moving from cattle to containers. So why not take that last step and let containers be just a point somewhere in the middle of that process and move away from that into unikernels, and then as unikernels as a service where you just run your code somewhere in the cloud. All right, so are there any questions? All right. Well, thank you for attending. Thanks for being here.